Welcome to this EWRB Electrical Service Technician Training course. I'm Aria, an electrical tutor working with Whitroy. In this course, I'll guide you through all the topics covered in the EWRB Electrical Service Technician Exam Teaching Guidelines. Welcome back. In our last lesson, we explored safe working practices, where we learned how to isolate, test, and verify a circuit before working on it. Now, we'll focus on the tools that allow us to do that testing safely and accurately. This is Topic 8.17, Electrical Testing and Measuring Instruments. As an electrical service technician, your test instruments are some of the most important tools you own. They help you confirm that equipment is safe, detect faults, and verify compliance with AS/NZS 3017 and the Electricity Safety Regulations 2010. Let's begin with Topic A. Topic A. Purpose of electrical testing and measuring instruments. Electrical testing instruments allow us to measure voltage, current, resistance, continuity, and insulation resistance, and to verify correct polarity and earthing. Their main purposes are: 1. To confirm that circuits are correctly wired and safe to energize. 2. To detect open circuits, short circuits, or insulation faults, and 3. To monitor performance and ensure compliance with New Zealand standards. Without accurate testing, you can't prove your work is safe, and as we learned under Regulation 16 of the ESA, all work must be tested before being put into service. Topic B. Types of testing instruments. Now let's move to Topic B. Types of testing instruments. There are several categories of instruments used in electrical work. Let's go through them one by one. 1. Multimeters, measure voltage, current and resistance. Modern digital multimeters, or DMMs, are the most common. 2. Insulation resistance testers, often called megas, measure how well the insulation resists current flow between conductors and earth. 3. Continuity testers, check that a circuit path is complete and has low resistance. 4. Clamp meters, measure current without disconnecting conductors. 5. Voltage indicators or proving units, confirm that a circuit is live or dead before touching it. 6. Earth resistance testers, used for testing earth electrodes and bonding conductors. Each instrument has a specific purpose, and knowing which to use, and when, is part of being a skilled technician. Topic C. Analog versus digital instruments. Now let's talk about Topic C. Analog versus digital instruments. Analog instruments use a moving needle across a scale. They're excellent for observing slow voltage changes or fluctuations, but they can be harder to read precisely. Digital instruments, on the other hand, show readings as numbers on a screen. They're faster, more accurate, and easier to interpret, which is why most technicians today use digital multimeters. However, digital meters can display false readings in noisy or unstable circuits, so always check by measuring twice or using a second instrument if in doubt. So in short, analog meters are better for trends. Digital meters are better for accuracy. Topic D. Safety categories, CAT ratings. Now let's move to Topic D. Safety categories, also known as CAT ratings. Every test instrument must meet a minimum safety category depending on where it's used. Here's how to say it clearly. CAT 2 instruments are suitable for socket outlets and appliances. CAT 3 instruments are for distribution boards and fixed wiring. CAT 4 instruments are for testing at the origin of the installation, for example, main supply and switchboards. Always choose an instrument with the correct CAT rating for the environment. Using a lower rated meter on a high-energy circuit can result in an arc flash or instrument failure. As a rule of thumb, for switchboard testing, always use CAT 3 or higher. Topic E. Safe use and maintenance of test instruments. Now let's move to Topic E. Safe use and maintenance. Before using any test instrument, inspect the meter and leads for cracks, cuts, or exposed conductors. Check the probe tips are tight and clean. Verify the meter's function by testing it on a known live source before and after use, the same prove test prove rule you learned earlier. Always set the range higher than the expected voltage when measuring, then reduce it for accuracy. Never use a resistance or continuity setting on a live circuit, it can damage the meter instantly. Calibration is also essential. Meters must be checked and calibrated at least once every 12 months, or sooner if dropped or exposed to moisture. A misreading meter can cause unsafe decisions, so always trust a calibrated instrument. Topic F. Common electrical tests. Now for Topic F. Common electrical tests. Let's go through the spoken explanation of each main test and what readings to expect. 1. Continuity test. Purpose: to verify that conductors are continuous and that the earth loop is complete. Method: use a low ohm range on the meter, with the supply isolated. Expected result: less than 1 ohm from the earth terminal to exposed conductive parts. 2. Insulation resistance test. Purpose: to check for leakage between active, neutral, and earth conductors. Method: use a 500-volt insulation tester with the circuit isolated. Expected result: at least 1 megohm, for readings above 10 megohms are preferred for new wiring. 3. Polarity test. Purpose: to ensure that the active conductor is connected to the correct terminal, for example, the switch or fuse is on the active, not the neutral. Method: use a continuity tester or a test lamp, depending on whether the circuit is live or dead. Expected result: correct polarity, the active must be switched, not the neutral. 4. Voltage test. Purpose: to confirm that supply voltage is present and within tolerance. Expected result for single phase: around 230 volts plus minus 6%, for 3 phase, around 400 volts plus minus 6%. 5. Current test. Purpose: to measure load current under normal operation. Use a clamp meter to avoid breaking the circuit. Compare with the rated current on the nameplate. Excessive current indicates overload or faults. These are the standard verification tests specified in S/NZS 3017 Clause 2.3. Topic G. Interpreting test readings. Now let's talk about Topic G. Interpreting test readings. Testing isn't just about recording numbers, it's about knowing what they mean. If you measure high resistance on a continuity test, that suggests a loose connection or corrosion. If you measure low insulation resistance, that indicates moisture, damaged insulation, or contamination. A supply voltage significantly below 230 volts can suggest a voltage drop due to undersized conductors or a bad joint. A current reading above nameplate value indicates overloading or a motor fault. When readings don't make sense, don't ignore them, investigate the cause. Correct interpretation separates a true technician from someone who only uses a meter. Applied example: safe use and maintenance of test instruments. Let's finish with a practical example. You're called to a customer's house because several lights have stopped working after a storm. First, you isolate the lighting circuit at the switchboard and lock it out. Then you perform a continuity test between the neutral bar and the lamp holder. Neutral, no continuity. That indicates an open circuit. Neutral. Next, you test insulation resistance between active and earth. It's above 200 megohms, meaning insulation is fine. After checking the fittings, you find a loose neutral in one sealing rose. You re-terminate the connection, test again for continuity, now it's less than 1 ohm. Finally, you re-energize the circuit, measure 230 volts at the lamp holder, and the lights work perfectly. This example shows how electrical testing identifies faults logically and safely, no guessing, no risk. Bringing it all together. Let's summarize Topic 8.17, Electrical Testing and Measuring Instruments. We began with the purpose of testing, to prove circuits are safe and compliant. We covered different types of instruments and compared analog and digital meters. We explained CAT safety ratings, safe use, calibration, and the standard verification tests. We learned how to interpret readings correctly and applied that knowledge to a real lighting circuit example. Every test result tells a story, and it's your job as a technician to read that story accurately. Checklist summary. Here's a quick checklist to memorize. Inspect, prove, test, record, interpret. Repeat it. Inspect your instrument, prove it works, test the circuit, record the readings, and interpret the results. Summary. To wrap up, always use the correct instrument for the job. Check CAT safety ratings and calibration. Never test a live circuit with a resistance setting. Follow /NZS 3017 test procedures step by step. Understand what your readings mean. They prove safety and compliance. That concludes Topic 8.17, Electrical Testing and Measuring Instruments. In our next lesson, we'll move on to Topic 8.18, Electrical Appliance Testing, where we'll learn how to inspect, test, and tag portable appliances safely in accordance with /NZS 3760, a key skill for every electrical service technician.